So this is the startup page on my Chromebook. If you don't know yet, to use GeoGebra, you must choose the GeoGebra icon, usually in the lower left-hand corner. Somewhere in your list of icons, you'll see a GeoGebra icon. It's white with circles. Choosing that, it opens up another tab in the Chrome browser. And so I'd like you to select, for this particular task, the algebra option. This is what your screen looks like, and we're now going to input some information from section 4.5, the set question number 7. This is just a recap. So I'm looking at this information here. I've got my packet out, and I'm going to look at the question number 7, which is there. Now question 7, we want to graph this using GeoGebra, and then we want to analyze which of these functions has the greatest amount of change. In other words, per the directions, it says that compare the rates of change of each of the functions and identify the interval where it appears that f of x is changing faster and where it appears that g of x is changing faster. So let's do that. We've done this before, but I want to put this out there so that you have a model on how to use GeoGebra using the Chromebook. So make sure you select your input portion on the left side of your screen. Select that, and then type the function as is. Don't make any changes. The exponent option is there. It raises your blinking icon. Use the right arrow key to get out of the exponent field and add +1. Let's try that again. There we go. Make sure you're out of the exponent field. If you're in the exponent field and type +1, it's part of the exponent. We don't want that. Now let's graph that and see what it looks like. So there it is. And you can move your window by choosing this option here, the Move Graphics tool. Click and drag. And so there you have it. Now let's type in the other equation. Just remember that once you're in that Move tool, select out of it by going back to the mouse button. Now here's my next function. It's g of x equals -2x minus 2. Enter. And so now I have both of my functions. Now what I'd like to do is just take a look at that graph. Again, I got rid of the keyboard, right? Getting rid of that, and there it is. I want to look at these rates of change. Now I do this several ways by just making some just visual comparisons, and we did this yesterday by creating this vertical line that divides the graph into two parts. So let's try that again. So pick a point, select that point on the x-axis, make sure it's on the x-axis. Remember that your crosshairs turn into an arrow when you're on the x-axis, and there's my point. If you make a mistake and start clicking elsewhere, then you can easily undo that by choosing that option, the undo option, and always go back to your pointer option. Now let's draw a perpendicular line passing through point A. Okay. So I clicked on A, nothing happened. Click on the x-axis, and there you go, it draws it. Go back to your pointer option, and now drag point A, and you'll see that it intersects these two graphs. You see how that works? It intersects. Now what I'm interested in, and maybe I'll zoom in here, 2 fingers, if you slide downward, you can zoom in. But what I'm interested in is, when does it appear that if I was on the function f of x, that steepness, when does it appear that that steepness becomes greater than the steepness or rate of change on the function g of x? So here they look about the same, don't they? If I was looking at it, they look about the same steepness, about 0.5. But once I move beyond that, you'll notice that f of x looks like it becomes steeper. So at this point here, right there, if I was on that curve, it looks like I have more of a downward trend than I do if I was on the function g of x. See that's not as steep. So that's what you're visually inspecting. And so I'm thinking at 0.5, looks Looks like they have about the same steepness. It's just my gut. Maybe they don't. That's what I'm assuming. Now, when does g of x have a greater rate of change? Well, let's move this down a bit. It looks like if I drag to the left, I can see now that that steepness is, look at the f of x, that's far more flat than your function g of x. So the rate of change is less. And so I kind of get a visual idea of when that occurs. Looks like when x is less than 0.5, g of x has a greater rate of change. And when x is greater than 0.5, f of x has a greater rate of change. But I want to look at a table of values since that's what the directions say. So how do I do that? And this is big idea. So what I'm going to do is I'm going to take this video and I'm going to end it. And then I'm going to set up part 2 on a separate video so that this one isn't too long. Make sense? All right. So let's end this video.